Okay, thank you, Sergey. And last but not least, we have Brett Singer from Lawrence Berkeley National Laboratory, and he's going to be talking about specific consideration of mitigation of PM exposures in low socioeconomic status households.
Great, thank you very much. And Rich had told me I was the least. That's why I was last, but I guess thanks for pointing that out. Thanks a lot, Rich. So I'm going to start with a summary just because I'm the last, and in case everybody leaves, you at least get the key things to start. We actually know how to greatly reduce PM exposure in homes, and that's all varieties of PM. There are many measures that we can do that involve both technology and practice or behavior. That's a very important point. Source control, it's usually where we start. It definitely can work, but it requires behavior change, which for most of us who are people know it's difficult. Durable progress occurs through standards and codes for both buildings, but also for appliances and the products that we use in our houses. I'm not going to spend a lot of time talking about that, but I'll touch on that. In existing homes, solutions may be constrained, and some solutions are actually fairly costly. Okay, some solutions are cheap and some are not. And then the mitigations often are more challenging in the low SES households. So thanks to Gary, I don't have to spend a lot of time. I'm going to go through this very quickly about what is low SES. What I will bring up is we often equate it with low income, but it's obviously a lot more than low income. And one particular thing I want to point out, it's low education, but even more importantly, it's low status and low access to information. So we're here now, okay? Hopefully there's a whole bunch of low SES people, low income people, people with limited education who are watching this online. Okay, but probably they're not. Probably they're out working or taking care of their kids or doing whatever. Okay, so this limited access to information is actually very important, especially when we're talking about changing behavior or practice. And it's people who are just struggling to get through life. So when we talk about these fixes, okay, something that will work for a family that has it all together might not work for a family that's struggling just to get through the day. So what are the challenges? Gary, again, talked about a lot of these things. So I'm going to just go through this. I think all these things were covered by various people today. Economics we mentioned. I want to point out the two of these things. One is when we talk about low cost, right? What's low cost for me is going to be very different than what's low cost for somebody who's trying to raise a family on four on $30,000, $20,000 less per year, okay? A lot of times they have no credit, or if they have credit, it's very costly. So even things like, you know, ordering a filter online or going to Home Depot to buy a filter, these things that we take for granted are not so simple. And there's limited or no choice in the housing. They have the housing they have, they can't move, they can't readily change it. And then the sociological elements are very important as well. Limited status demand repairs, right? So there are a lot of renters, so theoretically their houses, their homes should be taken care of for them, but they're not, and they don't want to complain because they're worried about getting thrown out and they don't have an alternative. The language and the digital divide, complicated cohabitation arrangements, right? So you're staying with your brother because that's the only place you have to stay, and he smokes. So you can't tell him to stop because you're there as his guest. And then cultural norms. You can't tell grandma not to burn her incense in some families because she's the matriarch of the family and that's what she's going to do. So we talk about mitigation. So that was the low SES, and I'll come back to that. Now the controls, we often break it down in this way of source control, ventilation, and air cleaning or filtration. I'm going to choose to look at it a little differently and say, from the source perspective, we can reduce the PM that's coming from outdoors. We can reduce indoor sources, indoor emissions, or we can accelerate the removal of stuff that's already in the air inside. I think that's a helpful mental model to have. And if you think about it, we've been talking about these things through the day, right? So source control is reducing the sources, reducing it coming from outside, and then all the filtration stuff is this last one. So again, this was talked about a lot of why do I start with reducing PM from outdoors? Because it's going to always be there. If we do nothing, we're going to have PM from outdoors. So let's start there. I'm going to spend a couple minutes now on a series of figures that are a little more complicated, but I think are worthwhile to elucidate some of the processes. So these were experiments that our group at LBL did in a unoccupied test house we rented for the purposes of doing testing. It was in Sacramento. It is in Sacramento. It's about 300 meters downwind from I-80 freeway. And we instrumented the house. It's a moderately tight house. It's a 5 ACH 50. That means it's 5 air changes per hour at a 50 Pascal pressure difference. So the tightest houses are less than 1 ACH 50. Pretty leaky houses are more than 20 ACH 50, so it's kind of in the middle. And I'll show you some stats on house air tightness in a few minutes. And then what you're looking at here is we put 7 or 8 different ventilation and combinations of ventilation and filtration in this house. And then we'd run them for a week at a time, switching back and forth. What you're looking at here is a baseline condition where we just had exhaust ventilation at the ASHRAE 62.2 compliant rate. That's a ventilation standard. So there's a baseline mechanical ventilation here. That's an exhaust system. On the bottom, you're looking at, this is actually a calculated PM 2.5 from size resolved measurements, but it's close enough. We had some other measurements there. And on the top of this, the gray band is actually the 1-minute data. The black line at the top is 1 hour average data. And then on the bottom that's the outdoor. On the bottom is the indoor data, same thing. And then the red is, if the red's coming through, is the 24-hour average. It's a running 24-hour average, and that's why it starts a little later. And then on the top, we have the indoor-outdoor ratio. The red line is the 24-hour average indoor-outdoor ratio. And then there are little triangles on the bottom and the top. The triangles are the highest 1 hour each day. And what we did is we took the highest indoor 1 hour each day, and then we tracked it back to the highest outdoor that corresponded, or we did it the other way around. Maybe it was the other way around. In any case, it's basically it's a short-term value. It's the highest short-term value outdoors and indoors. Okay, and then we looked at the ratio of that as well. So now let's talk about the interesting features. Okay, so the first thing is we've talked about outdoor PM, and this is not an outdoor PM, but we've referred to variations in outdoor PM. Well, there's very important temporal variations in outdoor PM. So this is a winter week in the winter time. So we see a typical winter pattern over the first few days where we see very high concentrations in the overnight periods corresponding to just a smaller atmosphere. Daytime, everything heats up a little bit. The atmosphere expands. So the particle concentrations outdoors go down pretty dramatically. You see these very big swings. And then in the last few days, there wasn't as much of a diurnal profile and temperature, and then the particle levels didn't swing as much outdoors. The indoor levels are obviously much lower. If you look at the 24-hour averages, they're about 60 to 70% lower indoors than outdoors. That's consistent with numbers we've seen from larger studies. But one of the features I want to point out, if you look in the first couple of days here, there's times when the outdoor concentration actually gets almost as low as the indoor because the indoor has to kind of catch up, right? So and I'm going to actually pause for a second here. We talk a lot about ventilation, right? And we're focusing today on particulate matter, but we don't ventilate our homes only to manage our exposure to particulate matter. We ventilate our homes for lots of reasons. We ventilate for moisture management. We ventilate for exposure to other chemicals that are produced indoors, okay? So there's lots of things. Formaldehyde, every bit of ventilation you do is going to reduce your exposure to formaldehyde for the most part because it's much higher indoors, a lot of the VOCs. So so we do need to ventilate our houses. So there are times when we can ventilate our houses that are not as damaging for us from outdoor particles, and there are times that are less advantageous because the outdoor particles are much higher. So that's one feature. The second feature is that if you look up top, you see that the peaks are more reduced than the average, right? So this is the benefit of being indoors. This is nothing special about this house. It's true in most houses. And then again, we have the 60 to 75%. I'm going to go on to the next slide now. So the next point I wanted to make, this is ultrafine particles. And you see, consistent again with what we saw this morning, much greater protection for ultrafine particles. They are removed at greater rates as air infiltrates into the building, and they're also removed faster in deposition. And this is actually an unfurnished house. This is basically an empty house. You still see dramatic reduction. So having even a moderately tight house really protects you a lot from outdoor particles. The next plot is for black carbon. We talked earlier about elemental carbon. This is an indicator of diesel. I like this one because there's a lot of complexity going on when you look at a black carbon or elemental carbon inside. right? So there's, the absorption, desorption, all this other stuff. But we have lots of health data that correlate health effects with exposure, indoor exposure to black carbon, okay, which is an indicator of this diesel particulate matter. So reducing your exposure to black carbon is a pretty good indication you're actually reducing your health burden. But what we see here is that the result is much less. There's much less benefit for black carbon. It's because of the size. And this is, again, consistent with things we saw this morning. And even more so where you see there's periods of the day where the outdoor black carbon actually drops way down and is much, much lower than it is indoors at the same time. So this is actually the results of the filter part of the study. So over on the left, you see the reference system. So again, that's the 60, 70%. This is, again, the indoor-outdoor ratios. So an indoor-outdoor ratio of 0.3 or 0.4, it means a 60 to 70% reduction in the outdoor particles. And then I just wanted to make the point here, Jeff mentioned having good ventilation systems, right? And there's different places you can put your filtration. So people like to think, oh, I want to filter the supply air because that is the most efficient way to reduce my outdoor particles. And that works really well. If you put a MERV 16 on your supply, you could just completely take away your exposure to outdoor particles, okay? But if you have a MERV 13 filter on a recirculating system, then you bump up your effectiveness from 60% up to 90 to 95%. Okay, so you can get very effective outdoor particle reductions with a recirculating system as well, and you can do that with efficient systems, energy efficient systems. This is a slide, this is some work from Brent Stevens' group. It's a little complicated, but going across the bottom, you see different levels of MERV filtration, and then the groups of data points are different, basically, air tightness levels. And what you see is protecting from outdoor particles, you get these big bumps as you make your house tighter, and then you get some increase also with the filter quality, but as you improve your shell, the filter doesn't do as much for the outdoor particles, but the filter then does a lot more for the indoor particles. I mentioned air tightness. I'm going to skip over this relatively quickly because I want to get on to some other stuff. But what you see is that the air tightness of homes has gotten much better over the years. We're just building homes tighter. And then if you look even new homes, this is from California, new homes are less than 5 ACH50, so that's great. So then the question is, well, what about existing, right? So yes, when we're building new homes, new multifamily buildings, we build them nice and tight. That's great. You can actually substantially reduce your air leakage through retrofit measures. So for regular single-family homes, you can't see these numbers at the bottom maybe, but the median reduction was about 20%. In low income, they start out leakier, but you can get bigger reductions. So this isn't like special programs. This is just kind of what's happened is weatherization. It's a great program. You can do better than this, right? So the best homes, you reduce them at higher rates than this. But just right now, random people doing weatherization are achieving median reductions of 30% on the infiltration. And I mentioned to Bill between the sessions, I was going to answer his question. So the question that Bill had asked earlier was, is it better to ventilate more or ventilate less? And one of the answers I would offer is I think the important thing is to be able to control how much outdoor air you bring in. And if you have very leaky homes, and you can't do that, if you at least start with a relatively tight home, then you can pick the times of when you want to open the windows and when you want to filter, et cetera. And I'll get back to that too. So then the question, I'm going to go to indoor sources now. As we've talked about, it varies greatly by home in terms of what are the most important sources. If there is smoking in the home, it is definitely the most important source, I'd say, in almost all cases. There are some other things that are habitual behaviors that I think, if that habitual behavior is happening in the home, that becomes the most important source. So cooking, okay, I mean, we think habitual is a bad thing, but cooking is kind of a habitual behavior. People tend to cook. People who cook at home, if you do a lot of cooking at home, that's going to be a big source. If you burn candles or incense, that might be your most important source. There are people who burn candles and incense pretty much all the time. Okay, so that would be an important source. And then some of the other things. I won't spend a lot of time talking about this picture, but this is a nice study done by Lance Wallace and colleagues. And they put this data together in a very nice way that really elucidates. On the top are homes that have smoking, and the bottom are homes that, the red is homes that don't have smoking and don't fry regularly, and the black is homes that do fry regularly. And you see a a pretty big bump between the red and the black, okay, when you put a whole bunch of data together. So one word about smoking, and then I'm going to talk about cooking. On the smoking, one of the real victories, I think, one of the real success stories, I used to do a lot of secondhand smoke work. Tobacco control community has done a great job in getting people to ban smoking in their homes. And it used to be big differences between what I would call low SES, so low income, low education, and higher income, higher education people you see over on the left. But that gap has closed a lot. So there are lots of low income homes, there are lots of homes with lower educated people. Lots more homes in general have smoking bans in them. So I don't think this necessarily means that there's zero smoking, but if someone is reporting a smoking ban, it stands to reason there's probably a lot less smoking. So I'm going to say one or two more things about smoking, actually. Smoking cessation. I was surprised. I went and I spent an inordinate amount of time trying to find this. I thought there must be lots of studies out there showing the benefits of getting people to stop smoking. So I wanted to show the measured benefits of smoking, instituting a smoking ban, smoking cessation, et cetera. This was the best study I could find, actually, and it was imperfect because the numbers weren't large enough. So there was this is the same group. They modeled this and they said, oh, I think this was in the UK, and they said, well, we for a typical 11-year-old, we think we can get the PM 2.5 in a smoker's home from 31 micrograms per meter cube down to 3.5 with, you see the ranges up there. So, 90% reduction. And then they went out and they did this nice intervention where they measured pollutant particle concentrations in the home. And then half the group, they showed those results to the mother and say, hey, this is what happens every time you smoke in your home. And here's the health standard, and here's where you are, okay? And the other half, they didn't show them the data. And they came back 4 weeks later, and they measured it again. And these were the results down here. So the controls went from a geometric mean of 25 micrograms per meter cubed with a pretty big geometric standard deviation. It went from 25 to 24, and the intervention homes went from 19 down to 11. But because of the relatively small numbers, these were not statistically significant differences. I think the P was like 0.23 or something. But we didn't see the 90%. If it had been 90%, we would have seen it. Here's another one. So this was a great study by Stu Batterman where they used, and there were a couple of studies like this where they used filters in homes that had smokers. These were both smokers and non-smokers homes. So you're looking at the mean and standard deviation of a particulate matter without filter use and with filter use. This was a portable or standalone air filter. I think it was in the child's bedroom. So it was a limited spatial thing. And you see both in homes with smoking and without, so with secondhand smoke tracer and no secondhand smoke tracer, you see very large and statistically significant reductions in the particulate matter. Great. So the filters work. We sort of know that. Very clever, though. These guys are great. So then they went out and they measured, they tracked the filter use in between the times that they were there. Okay, and I think without being able to read the bottom, you could probably guess which of these correspond to the times that they were there, making measurements in their home and the times in between. Okay, great. A couple words about kitchen. There's a couple different ways to do kitchen deal with cooking. The best is the range hood down on the left here, a venting range hood. There's a lot of times you see an exhaust fan on the wall or in a ceiling. It's very common in apartments. You can do downdraft, and then, of course, the old standby open window. This point, I think, was brought up earlier. I want to really emphasize this, especially for all the people viewing, remotely. Just because you have a device above your stove does not mean that you have kitchen exhaust ventilation. And there's a couple ways you can tell. If there's a big duct running up from it, maybe there's a cabinet, you can open a cabinet, and you see a duct. More than likely, it's actually exhausting, but not always, mostly. And if you can feel air coming out, blowing back out through these the grill here, then it's definitely not exhausting. It's definitely blowing back at you. Okay, so those are, and it's worthwhile to check this because you at least want to first know what your situation is. Because if you don't have a vented range hood, then you want to use some other kind of ventilation when you cook. Do they always work? We talk about it like it's a simple solution. Oh, you put a vented range hood, so that just takes care of the problem, right? Well, unfortunately not. They don't all work as well as we would like them to. We have studied this. We use a metric called capture efficiency, which is basically just a fraction that gets of what's emitted that gets taken out before it mixes into the room. We're working with ASTM to develop a standard test for this so we can report it to people what the capture efficiency of the products are as a first measure toward putting it into standards. We've done a lot of measurements of the capture efficiency. So another number, we have it between 0 and 100%, which is really just between 0 and 1, right? So it's another one of these efficiencies. And on the top, we see the efficiency of cooking on the back burners. And on the bottom, we see the efficiency of cooking on the front burners. And this is measuring 7 hoods in our laboratory. And you see on the back burners, if you get up to about 150 CFM, then most of them are doing pretty well. They're 70, 80% or greater efficient. But on the front burners, there's a real variety, right? So in the front burners, at that same 150 CFM, some of them are down at 40% capture efficiency, which means 60%. Now, it's still better than 100% coming into your house, but 60% of what you're cooking or more is coming into your house. When we go out to the field and do this in homes, it's much worse, okay? And the reason it's much worse is that the fan flows are not as great. The positioning is not ideal. There's lots of, the grease screens are clogged. There's lots of reasons why these work worse. You will still see, if you can tell colors, that there's a preponderance of blue, which is the back burner, that are higher up. And you do see that some of these hoods work really well. They're all 50 to 100% in all the conditions. And in general, they're the more expensive ones, okay? Just a quick note, everything you saw previously was capturing the gases. So that was based on the carbon dioxide coming from the natural gas burners. We did work looking at particles from cooking. We did a stir fry and a pan fry. And so on the back burners, they do pretty well for particles as well. But on the front burners, the efficiency for particles just crashes, okay? So you have to have an exhaust fan, you have to turn it on, and it's probably going to be much more effective if you cook on the back burners. A couple bits of news you could use. We mentioned some of the problems with behavior. So this is some data from California. I think these are maybe slightly high in terms of how often people use them, but some small fraction of people say they use them all the time. Some more people say they use them most of the time. A lot of people say as needed. Right? So what do they mean by as needed? It's usually when they burn something or they're cooking something really stinky, okay? Now, that's good, right? If they burn something or they're cooking something really stinky, then yeah, definitely vent. But all those other times, they're still being exposed to ultrafine particles. They're still being exposed to nitrogen dioxide if it's gas. If it's electric, you're getting ultrafine particles. So this is not really sufficient. And then the reasons why they don't use it, basically, it's I don't think I need it or it's too noisy. The challenge is many homes don't have kitchen exhaust. Much of the installed equipment doesn't work well, too noisy, people don't use them. And then if you want to ask me about this later, we can. But we mentioned Melissa London. This is also thanks to Melissa London. 10-second story. After I had my roof replaced, talk about knowledge, this is what I pulled out of the duct above my range hood, okay? My range hood would never have worked again if I heard something didn't sound quite right, so I pulled the range hood down, and this is what was, and the way they work is there's a little, basically sheet metal flap that opens up when you turn your fan on, okay? And that would never have had any flow ever again if I hadn't pulled this down. One roof replacement. Costs. So we talked about things being relatively inexpensive. Well, again, everything's relative. So we talked about standalone HEPA filters. Standard units maybe are half a dollar per square foot. These are ballpark numbers I picked out from looking on Amazon or Home Depot or whatever. The quiet low power ones are about $1. So if you want to cover 500 square feet of space with one of these things, you're going to be spending $400 to $500 for a really good, quiet, energy efficient unit. You can buy a less efficient, noisier unit for maybe half that amount. And then the filters also scale with the quality. So, you know, $20 to $30 for the standard filters, but for those really good units, $80 to $100 every year, year and a half. That's a chunk of money, especially, I mean, it's a chunk of money for me, and it's probably a lot of you. You're going to think about it. If you're low income, you're not going to buy it. The central HVAC filter is one of the advantages. If you get the central system right, then the filters are not that expensive. But as you start ramping up, $20 to $30 for a filter, again, it starts to maybe enter your mind, is this really what I want to spend? If you're running a low-income housing unit, right, then that, again, to change out all the filters in the unit starts to become more expensive. And then the range hoods, you can get a crappy one for under $50, but the ones that are quiet enough that you're going to want to use them all the time are a couple hundred or more dollars. Okay, can I just do the recommendations and then I'll stop? I was at the 1 minute, yeah, okay. So the best control starts with good buildings. I mentioned the airtight envelope. I really think that is where you start, but you do have to take care of the indoor sources. You want a vented range hood that is quiet and captures pollutants. You want your central forced air, if you have it, okay, because more and more homes may be without it, but if you have it, to be set up for filtration, that means you have an efficient blower and ducts, so you're not spending a lot of money or energy to accomplish that filtration. You have a good deep filter slot, and intuitive controls is really important. So another way that controls or interventions are defeated is you put this nice system in, you put the thermostat set up for the filtration to come on for 20 minutes out of every hour or run continuously to low speed. And then the first time something happens that the people change it, it never gets reset. Okay, so that control is gone. So you need to have that both smart and intuitive controls, robust venting of combustion appliances, limited use of carpet. Rich, thank you, pointed out that you don't want to always get rid of carpet, especially for some elderly people. It helps with slippage. So there are cases where carpet is certainly fine. And then there's some alternatives if you're in an existing building, so you can reduce your infiltration. If you don't have a venting range hood, you can put an exhaust fan in the kitchen, or you can use an exhaust fan you have elsewhere. Maybe use your bath fan or a fan elsewhere in the house, a laundry fan. And then people can take actions to help close windows to reduce outdoor PM. Again, this is with the knowledge. There are general rules that we could offer, maybe EPA could offer, in terms of when it's a good idea, if you want to reduce your exposure to outdoor air pollution, to keep your windows closed, and when is a better idea, because it's very seasonal. It might be dependent on where you live in a city, but still there's general rules you can follow. I mentioned the cooking on back burners. Using the HEPA vacuum, I think in general is a good idea. Investing in good filters and using filtration. And then I'm just going to say one last word here, and I know that this is going a little over, and that is, we're talking a lot today about indoor PM, right? And I think all the people in this room are aware of this, but also for the people at home, maybe this is a good summary point for the day. We realize this is one element of your indoor environment. So somebody alluded to this earlier in a question for Gary. I think it was Rich, saying when we build better housing for people, okay, a lot of things improve all at once. And that has improvements. All of those things may contribute to the improvements, the health improvements that we see. And rather than split hairs and say, oh, was it what element of the green housing? It was the fact that we were paying attention to provide really good housing for people. And if we provide really good housing for people, we're going to see benefits to that. So I don't want to lose track of trying to identify the specific measures that are most valuable, but the collective, the holistic approach to providing good housing for people, and we get a benefit from that. Let's not lose sight of that either. Thanks.